Well, it's a little late in the week here. It's Sunday. You guys are probably finishing up week 6, and I just felt a little like I didn't do a good job talking about the group index. I want to go back over it. I have done it two, not different ways, but just simplified it a little bit. But first, I have up on the screen right now is a pretty good little uh, document about calculating group index. What the group index is it's the final thing that you do when you're classifying a soil. Now, you've seen a video of using the AASHTO chart. You'll see another one with me trying to work one, and we'll get to where we're a little bit more comfortable with the chart itself. And we've yet to calculate the percent passing, and we will do that also. These other things are not that hard. If you will go into your book, chapter 1, it is, I think, there's a sample problem uh, that's, I think, kind of easy to explain. This the first thing we have to get when we're first thing we have to get when we're going to classify soils is to see the how much of the soil after the sieve analysis has passed through which sieves and how much has not passed through it. So on page, let me find it, chapter 2, engineering properties of soil. There's a whole lot to look at there. We may review some of it. Most of it, if you went through certificate programs, perhaps you saw it either there or in that NCCER Soils module, that NCCER Soils module that we used way back early on within the first 4 weeks. We covered that module. So we probably weren't through some of this. We may revisit it a little bit, but it's going to show. This is on page 8 in your textbook. I'm sorry, 6, where it's section 2-1 soil types, and then it goes to 2-2 on the next page 7, and that's grain size analysis, and it shows you a picture of the sieves, and talks a little bit about how that's done. Uh, so look at those 2 pages. Now on page 8, it says example 2-1. Well, that's a problem. And I mean, that's not a problem for us, it's just a problem. So it's going to have some given, and in this case, it says an error. We'll go over this again before we do it. But it goes through the process of finding the percent passing, which is essential to the classification of soils and the developing a grain size distribution curve from this example 2-1. So that'll be another goal we'll have here. So for right now, I'm going to put that aside, and I'll have a video covering how to calculate percent passing, and then we'll have a few practice assignments and till we get a little bit more comfortable with it. But right now, I want to get back to the group index that I did a preview on, but I got a little hung up, believe it or not. Uh, uh, I don't know everything, but I think I've kind of got it a little bit more organized for myself and for you. And I did it in uh, more the cautious way, and then I did it in a pretty uh, simpler way. I just shortened the steps. So back to group index. Here is the formula, and you probably saw it in your tailgate. Uh, the group index is the F 200 is the percent of fines that pass the number 200 sieve. And then it says minus 35, and that's what I was calling last time a constant, but it's a variable that works when you're calculating group index. And then it moves on to these brackets or parentheses, and that's where we get a little messed up right here. For instance, real quick, we're inside of a bracket and we've got this 0.2 or 2/10 plus 5 thousandths, 0.005, and the parentheses multiplies it times the liquid limit. Well, in the case of you will be given your liquid limit, and you will be given some of these other variables. You'll have to have them. You can calculate some of them, but you would put your liquid limit minus 40, and then there's parentheses, and then there's brackets. We're doing PEMDAS. The parentheses, exponents, multiplication, division, adding, and subtracting. One of the rules about brackets and parentheses are essentially the same thing, I believe. It's just you want to do your parentheses before you do your brackets, but you will, after you do, that's the way I do it. After I do that, then I use my brackets and consider them the same as parentheses because they really are. Moving on a little bit, I've got my arrow on the wrong one. It's much clearer over here. The tests required will be, we're not going to do this. There are liquid limit and plastic limit tests. We'll be talking about this within the section on the Atterberg limits, and these are called the results of the test. And then the plastic size analysis test. So this goes on to talk about based on observed field performance, et cetera, and here are the general classification of soils. Up in here are the soil types, A1 and A to A8. A8 would be way on the right of your chart, and that would be an organic matter that we wouldn't use. A1 would be your best soils. And it has some rules in here. I'll try to get this posted so that you can have access to it. It goes into soils which have the same general load carrying capacity. In other words, the bearing capacity and serviceability characteristics are grouped together and classified into 8 groups from A1 to A8. And here they are, A1, A2, A3, and then A4, A5, A6, and A7. And they also have subgroups, which would be like A1, A7, A, and maybe it'll probably show us that in a minute. I can't quite get it out. Here we are. Nope, not yet. But the subgroups are just subgroups of like A1, and then it'll say A17 or A15 or A16. But all of those are more along the right side of the AASHTO chart, and they're usually in the fines or the plastics or the non-structural kinds of soils. So these are some rules, and I'll have to get this to you because I don't want to go through all of it right now. If the group index for your soil comes out to be negative, you got to just take it to 0. Here they are, A26, A27, following group index formula should be used. This one, in other words, that's a partial group index. But these are all plastic soils, so they don't need to go through all these calculations. So we'll get to that again. But here is something when you have talking about your liquid limit. When its liquid limit is 44, plastic limit is 18. So if you wanted to find your plasticity index, you would subtract your plastic limit from your liquid limit, and all of that will be coming to you again. So these are the most popular sieves for AASHTO classification. Here's the smallest size, and this is telling you, in this case, this is just an example that in number 4, everything passed through number 4, 100% passing. In number 10 sieve, 93.2% pass. And those are givens from the test. These will be derived from that test by weight. And here's your plasticity index I just talked about, liquid limit minus plastic limit. In this case, gives you a 26 for your plasticity index. And we will use that plasticity index in our group index classification. All you've seen so far is just a big problem, and I haven't had time to relate it to the I don't want to call this formula because it's not. It's actually, when you break it down, when we do a group index, we're simply just taking, I don't know if you noticed it or not, we're taking this side, the granular, mostly the structural soils. We're simplifying these and putting in the real numbers here, and then we're adding it to the more plastic side of it. And that's where it's an arithmetic problem. It's this plus this, but we have to keep going down, which I'll get to here very shortly. And back to the results of the sieve analysis. There's no way you're going to remember all this right now, but I'll get this posted so that you can have access to it, and there's more coming. This is talking about calculating it, and here's the formula again. These would be your percent passing the number 200 sieve. There will be a number that goes in there, and in the above case, that number was 60.2. And this right here would be your liquid limit that we saw before, minus 40. 40 is a constant, it'll be there. But this LL will be, minus 40 will be replaced with a single number, and the parentheses will be eliminated using PEMDAS. And then we add this side of the problem, which is in the more plastic side, I like to call it, but it still asks for the percent passing the number 200. So this number that goes here would be the same number that goes here. And 15 is another constant in this little thing here. See here, you're going to have, look at this right quick. You have 100, 0.01 times the percent passing minus 15. So to simplify this, we'd take that percent passing and subtract 15 from it, and that'd be a single number. And here you have the plasticity index that we saw a while ago, which is 26. And you minus 10, and your number would, your parentheses are gone, and you have a number 16 left for your formula. And that will become clear here shortly. Okay, I think we're done with that. So I'm going to try to switch us back to my calculations that I tried to show you in the previous video of my calculations, which didn't turn out so well, but that's okay. Sometimes it don't. Now this paper's been wadded a little bit. I hope we can see it clear enough. I don't have this in a file, so I'm just going to have to go through it little bit by little bit. Now, as you see, when we look at the plain formula that you have, all you see is this going across here because the numbers are all in it. But what you didn't know is, like, this is the plastic index or liquid limit. I meant to label these, but these came from calculations. From those Atterberg limits. So this is one of them, 17 minus 10. But what I really want to do, there's the plus, is this plus this plus this plus this. And it'll all come down to a very uh, simple this plus this. Uh, but getting there is what we need to do. So we're simplifying or reducing, like when you used to talk about fractions, perhaps that might ring a bell. But when we look up here, left to right, I wrote that in there. The numbers are already in here, but the parentheses are still here. The brackets are still here. And there's that plus sign. We'll be seeing that a lot as we go down here. When I calculated this, I what's called was trying to make sure. So you notice going down this sheet, I have the same numbers going down, down. I don't really have to do that, and I'll show you that in a minute. Actually, I'll show you that right quick. You see how long this thing is, and that's because I repeated the same thing because I didn't want to make mistakes, and consequently, look at this line here. It's 1710, 17 minus 10, 17. I could have changed that to 7 a long time ago. You know, I could have changed this to what is that, 18? No, uh, 33 minus 15. That's 18. See, I could have changed that to 18 all the way down here. I just was trying to make sure that I was getting everything in here right. But I believe you can do too much of this. But let's go back. And here's where we started. Right here. There's our percent passing. Let me get it off that. There's our percent passing minus the constant 35. And if you follow my little arrow, you'll see I got rid of those parentheses because we were multiplying this subtraction problem times this, and I need to get it down to one number. So I subtracted it, got rid of the parentheses, and it's minus 2. 33 minus 35 is minus 2. So I jumped over here, and I've got, this is part of the formula. 0.2 plus 0.005 times, this is the liquid limit, 46 that we were given a while ago, and it's minus 40, which is a constant every time. Liquid limit is 46 minus 40. I could have went ahead and changed that to 6, and I did. So, but on this side, I kept, I didn't do I didn't put this 18 in until way down here, and I could have done it any time. I guess I was a little bit anxious because I was stammering a little bit. But as we go down, we will start removing parentheses, but we want to make sure, and don't forget this little guy. PEMDAS, that's the addition and subtracting. That's the last thing. So you don't want to do that. And I did that. And that was one of my errors. Before, uh, uh, wait a minute. Here we go. I subtracted here, and here's where I messed up. I added in the, I've corrected this now. I added these two and then multiplied it by 6. See, that messes things up. Now over here we're staying the same, but that really threw me off, and I had to scramble and scramble, and I finally got it figured out. But I went back through it and made some changes to make it work out. That makes a whole different world right there, because when you multiply, when you wait, don't add it right now. I kept it before I added it, because we're gonna multiply this 0.005 times 6 here in a minute. I hope not too many minutes. And what we're going to get is this is the same thing going down. I still have it. But again, I multiplied the addition, which was 2. I guess that would be 0.2 plus 0.005 is what I used as a multiplier for the 6, but I didn't multiply it at that time. So what would that be? What would that 2 plus 0.005? Turn my calculator on. So again, I'm talking about the mistake I made, and it doesn't matter. I'll point it out here. Instead of multiplying this times 6, I added the 0.2 to 0.005, and that gave me 0.2 plus 0.005 equals 0.205. See, I was multiplying 0.205 times 6 because I added it. But that's not what I'm supposed to be multiplying 6 by. But when I finally got down to realizing that, so what I did first was I kept the 6, but I multiplied it by 0.005 instead of that 2.205. So you can see I got a way different number when I did it the right way. I hope you get what I'm talking about. I added before before I multiplied. I should have multiplied this, and then here is where it gets added. 0.2 plus, now because we've multiplied this 0.005, because we've multiplied it, that gives us 0.03. Now it's 0.2, this 0.2, this addition plus 0.03 instead of that 0.205. So you can see I got us way off base by making that mistake. Over here, I just kept it the same because this is a little bit simpler, but that addition thing really got to me. These will be done last. We don't have to add anything right now. I went all the way across working these when I did, but you could go all the way down on this side, and you could go all the way down on this side, and when you get to the bottom, you will have simplified both sides, and you will have, like, this is the correct answer, 0.46. I'll try to wrap this up and go to the one other thing I was going to show you is this is like the biggest thing about this is make sure if you don't like what you see, there's something wrong somewhere, and trust that there is, because if you don't like it, you won't see it. Because I came out with like a really high uh, index, group index. I couldn't get group in my mind. Isn't that weird? Okay. So going on down, when we have 0.2 plus 0.03, we have 0.23. And going across, I'm still haven't done anything until I get to right here. And you can see I finally did this, got rid of this parentheses, kept this side the same, and changed this 3315 to 18, and still holding on to 17 minus 10 in parentheses. Kept holding on, did change this, but I came up with the 2, 3, and I kept bringing it down. So we're still holding on to it until right here, and I finally let it go. And by the way, that minus follows this all the way down. That's a minus 0.46. Over here, you'll notice that I held on to this and finally let it go of the parentheses, and I turned out, well, 0.01 times 0.01 times 18 times 7. Well, 18 times 7, what is that? Am I doing this right? No. 7, no. I haven't let go. 18 times 7 right here. Let's see what that is. See, that finally has turned into 126 when I did that, but then as you can see, I had to multiply that 7 that 18 times 7, it comes out to 126. But when I multiply that 126, I'm sorry about this paper moving thing. I gotta fix it for that, I think. When I multiplied, as I have to do finally, this has been riding all along with me. And now we're to a point where I'm down to 18, I'm down to 0.01 times 18. Now what is that? I'm getting my camera and my phone and my calculator confused. So we're down to 126. I don't have that showing up here, but right here, if you multiplied 18 times 7, you would have 126. And you would bring that down, but you've got to take that 126 and multiply it by this, because we haven't done that yet. So let's do that and make sure. So 126 times 0.01 is 1.26. So there it is right there. Whoops. Right there. And it made a world of difference when I recommend, keep things lined up and kind of following along when you're working on this thing, but don't hold on to these parentheses like I did that long. There's no need in it. They're not going to change. You just make sure you're staying in line and doing things together on this deal. So the only other thing that I want to show you is by not holding on to things, this is what you would have. Same problem right there. Same problem. Look at the answer. I came out with 0.08. And you can see here is I was really wanting you to see the parentheses. This is dropped down to this F changed to 33 because that was a percent fines passing, the number 200 sieve. And then this 33 minus, this minus 2 comes from here. When I took these parentheses off, notice 33 minus 35 is a minus 2. So that's where we get the -2. And then all of this is the same thing I did over there. I just didn't keep holding on to them. See, I changed the 33 from 15. I took the 46 minus 40 right away and got to 6, and then I multiplied the 6 times, and that's my little line showing that I did, times 0.005, and that gave me that 0.03. And all I had in brackets then was that 0.2 plus 0.03, and that gave me 0.23. And see, I'm sailing along there, and here's where I showed the 0.01 times 126, which came from that 18 times 7, 126. And I tried to show a little bit of the 17 minus 10, where it came from, the 7 came from, the 33 came from. But it came down to 126, and it came down with the exact same number. I just was, the thing that really, when you mess up like that, this little guy right here, when I multiplied it uh, times 6, wherever I did it, when I added first and then multiplied times 6, that really threw me for a loop. And it's taken me a couple of days, honestly, to figure out that's what it was. I have to multiply before I add. I have to strictly think about PEMDAS as I'm doing this. And that's what I did. I was cautious, but I wasn't afraid to not, to let things go. And I drew these little lines mostly to demonstrate to you and myself, really, that that's where this is coming from. So I'm going to shut this thing down now, and we will be moving into week 7 when we start getting into that. The first thing we'll do in week 7, I think, is have a there's a video there. I think I'm going to just completely change it. It talks about some really good things, but it talks about the past too much. I made the video a year ago. What's in it is pretty good. I'll take one more look at it, but I may change that. And then you still have this 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 video before I revised it. Uh, I'm not sure what that looks like, but this is the one uh, right here. The video we're doing right now is the one you're going to need. So call me if you're confused on where I put these things, and you'll have to. This video is the last thing in week 6, so you'll see it down toward the bottom. I think. Have a good rest of the week. Uh, we'll get started on week 7 here this coming Monday. I believe it is.